Okay, moving on to 1.3, one more try finding experimental probabilities. All right, so it says in the last two problems, you conducted experiments to find the chances of particular results. You represented those chances as fractions or percents. The mathematical word for that for chance is probability. Okay, mathematical word for chance is probability. A probability that you can find by conducting an experiment and collecting data is called an experimental probability. So far in this unit, we've done a couple experimental probabilities. The first one was just flipping a coin and seeing how many heads versus tails we had. And then the second experiment, we took a cup and figured out if it landed on its side um, or end. Okay, that was our second experiment that we did. Okay. Suppose you do toss a paper cup 50 times. It lands on its head 31 times. Each toss of the cup is called a trial. Okay. So what you're actually doing, that's the trial. In this experiment, there were 50 trials. Favorable outcomes are the trials in which the desired result occurred. Okay. So in this case, a favorable result landed on its side occurred 31 times. To find the experimental probability, this is the ratio. It's always the number of favorable outcomes to the total number of trials. So, like in that scenario of finding the probability that it lands on its side, okay, and often this is the notation we'll use, the P and then parentheses side. What you would do is you'd write this equation. So the probability it lands on the side was be the number of times it landed on its side, which was 31, out of the number of times the cup was tossed. Okay, that's the total number of trials. The ratio of number of desired results to total number of trials is also called relative frequency. Okay, so a couple sort of big terms in here: probability, experimental probability when you find that based on experiment, trial, how many times you do it, favorable, or how many times it turns out for whatever you're looking for. And then that ratio is that relative frequency of favorable to total. All right, so Calvin's at it again. He's come up with one more way to use probability to decide his breakfast cereal. This time he's going to toss 2 coins. If the coins match, he gets to eat Cocoa Blast. So this would be a match, 2 heads or 2 tails. If the coins do not match, he eats Health Nut Flakes. So if he gets a head and a tail, he gets to eat the cereal he doesn't want. Okay, so suppose Calvin's mother agrees to let him use this method. How many days in June do you think that Calvin will eat Cocoa Blast? So thinking back to those 30 days, what would be your guess as to, or your prediction as how many times he's going to get to eat the cereal he likes, Cocoa Blast, okay, getting a match, or what he doesn't like, the Healthy Nut Flakes. Okay, so now we're going to do this experiment, okay, by tossing a pair of coins 30 times, okay? If you have 2 coins at home that you can use, you can toss, make sure you have 2 of them because you want to see what happens with both trials. Or I will also put in here the access to that random coin thing. So you would just have to go to flip 2, and then I changed it to 25-cent piece. I just used Pennsylvania. And then you just could flip the 2 coins digitally, write down heads and tails, or, whatever you get. Okay. So I can go back to this one though. All right. So I'll just model this for you a couple times. So 30 trials. It looks like I got tails. So I'm going to write both of those. And is that a match or not a match? Okay, so did he get to eat Cocoa Blast or not? That was a match. Okay, I'm going to go ahead and do it again. This time I had 2 heads. Okay, that was another match. Yay for Cocoa Blast. Okay, do it again. This time I got a tail and a head, so not a match. So I'm just put NM. Okay, so let's hear what he didn't want. So you're going to go ahead and do all through 30. So go ahead and do that now. Okay, based on your data, what's the experimental probability of getting a match? Okay, so I'm going to write that using some of that notation I just talked about. So what's the probability that I'm going to get a match? Okay, now everyone might have slightly different answers for this. What you're going to do is you're going to go ahead and just count up the matches that you had. Okay, and it'd be however many matches you had out of 30. would be your experimental probability. Okay, how about the probability of getting no match? Okay, so can you do that? So what was how many no matches did you get? So how many times did he have to eat cocoa or the healthy nut flakes out of 30? So you should both have numbers there. Okay. All right, we're going to skip this until tomorrow or till we're back together, the experimental probabilities, because we need to get our classmates' data. So when we're back together, we'll kind of compile that together. Okay, and let's move on to C, though. Okay, think about the possible results that occur when you toss two coins, and how many ways can a match occur? How many possible ways can a match occur? Did you say two? You can either get two heads or two tails. How many ways can a no match occur? All right, this is where he might have been fooled a little bit, okay? Because if you thought there was actually only one way, there's actually two ways, okay? Because if I look at my two coins, I could actually get tails and then head, or I could actually get head and then a tail, okay? So I could get a head on one coin and a tail on the other, or a tail on the first coin and a head on the other, okay? So it might have been a little hard to see. So if you actually looked at it, do you think match and no match have the same chance of occurring? Okay, so really you should have said yes. Okay, it really wasn't this fool of 2 to 3. It was actually 2 to 2. Okay, okay, so two ways for each. All right, let's look at question D. Calvin's friend Asher suggests that he toss a thumbtack. If it lands on its side, he eats Cocoa Blast. If it lands on its head, he eats Healthy Nut Flakes. She says they must first experiment to find the probability involved. So you guys know what a thumbtack is, right? So it kind of looks like that with a little tack that you would use to put up a piece of paper on the board. Okay, so it's either landing like that or landing kind of like that if this is the table. Okay. Okay, so if it lands on its side, it eats Cocoa Blast. It lands on the head, it eats Healthy Nut Flakes. She says they must first experiment to find the probability involved. Asher does 11 tosses, Calvin does 50. Here are the probabilities that they find based on their experiments. Which result do you think better predicts the experimental probability of the thumbtack landing on its head when tossed? Do you think Asher's or Calvin's, and explain why? Okay, so that's it for this lesson. Make sure that you've got your data and you bring that to class tomorrow so that we can compile it as a group. Okay.